Nästa gång får du
Okay, good morning. So let us start the lesson. One thing, I don't know how many of you checked that the video of last time was awful because of this microphone or something. So I wrote that I will make a video on the weekend, so I did it, and it was in 4K, so it is finished now. It is uploaded. Okay, so yeah, more or less I went through whatever I told you in that lesson. But of course it is hard to keep exactly the same words and things like that. But this time I went a little bit more smoothly and calmly. I was at home just drinking coffee, so it was easier to teach. Anyway, so that lesson is not missed. It is now on the YouTube. Now we continue our lesson with absolute values, which is actually very important. If I can manage it, I want to use GeoGebra simultaneously as well, to see how it works. Okay, so I hope that you don't have any problems with the notion of absolute values. So far we solved some problems together. Do you remember? So for example, what was the main point in the absolute value? Is that absolute value is ubiquitous everywhere in mathematics, but most of the time whenever you want to do something with an expression involving absolute value, you have to get rid of it first. For getting rid of it, you need to know the rule, yes? So the rule is nothing except the definition. If you want to remove this, you cannot remove it unless you know about the sign of the expression inside that. If you are certain that this is positive, you don't need to put this, you just simply write x. Of course, if x is equal to 0, absolute value of 0 is 0. And if x is negative, this you need to be careful. You are not just allowed to remove the pair of absolute value signs, but you have to apply a negative sign here as well, yes? But the important thing is that what would be the output of the absolute value? Inside the absolute value sign, you can put 0, you can put a negative number, you can put a positive number. But what you get at the end is a non-negative number, yes? The output is either 0 when I fit the absolute value with 0, what do I get? I get 0. But whatever except 0 I put in, I will get a positive number at the end, even if the number inside is negative. For example, if I ask you what is absolute value of 2, absolute value of 2, because 2 is positive, I just write 2. But what is absolute value of minus 2, because 2 is negative, I don't write just minus 2, I have to apply a minus 2 myself, but again the output becomes positive. So the output is either positive or 0, yes?
What do you do with complex numbers?
No, complex numbers, absolute value has a different meaning.
Okay.
But then that it comes back to this when it becomes real.
Okay.
Yeah, this will study in Math 4. Yes. Okay, so is that understandable? So let me just write you a remark. If I want you to know this, so remark. By the way, this is a symbol I want to use. This upside down A, I don't know, have I used this before here in this class? It means for all, yes? So for all x, this symbol means belongs to. You don't have to learn these symbols, but it doesn't hurt actually. For all x belongs to the set of real numbers. What can I say? I can say absolute value of x is always non-negative. I don't want you to memorize these things. I am writing these as remarks because I want to pay your attention to it. But otherwise, this is something that you need to know, yes? You will never forget this if you understand the notion of the absolute value. Especially if you know the geometric interpretation. Let us review this. So what was the geometric interpretation of absolute value of a number? So for example, when I say absolute value of A, what does this mean? Geometrically, yes?
Wasn't it the distance between A and origin?
Origin, yes.
Yeah.
That's the meaning. So it means that this is never negative, yes? If you are lucky, you are on the origin, your distance to the origin is 0. But if you are on the right or on the left, it doesn't matter. Your distance to the origin is still a positive number. So it's very understandable. Okay? So let me give you a nice problem using this idea. For example, let x and y be real numbers such that, for example, x plus y minus 2 to the power of 6 plus absolute value of 2x minus 4 is equal to 0. Determine the exact value. The value means exact, of course. The value of 3x minus 5y. So this is a good example. So let me write it here. X plus y minus 2 to the power of 6 plus absolute value of 2x minus 4 equals to 0. I don't know where should I start from. Okay, first let me start from this fact. If I give you a plus b equals to 0, so I tell you that I have chosen two numbers, capital A and capital B. They are in my head now. I give you one piece of information regarding those numbers, and I say that the sum of those numbers that I have chosen is equal to 0. Can you conclude both of them are equal to 0? No? This is not certain, yes? Might be the numbers that I have chosen, one of them is 2, the other one is negative 2. The sum is still 0 without being 0, any of them, yes? So from here, if you conclude that A is equal to B is equal to 0, this is false. Yes? But let me provide you with an extra piece of information. I tell you that again, I have chosen two numbers. None of them is a negative number. And the sum is equal to 0. Then can you conclude A is equal to B is equal to 0? In the previous one, I just told you I have chosen two numbers whose sum is 0. Then we learned that it is not guaranteed that each one of them individually is equal to 0. But now I am adding one extra piece of information for you. I am telling you that I have chosen two numbers in my head, the sum is 0, and none of them is negative. In that case, do you think I can conclude both of them are equal to 0? Yes. Yes. In that case, yes. Because if even one of them is not equal to 0, it should be bigger than 0 because I guaranteed you that I haven't chosen a negative number. If that one is positive and the other one is non-negative, when I add them, it becomes greater than 0. It cannot be equal to 0. Is that understandable? So this one is false, but this one is true. And A is non-negative and B is non-negative, then I can conclude A is equal to B is equal to 0. Yes? Okay, what do you think this has something to do with this situation? Do you want to explain?
Yeah, so if we could find out if they're non-negative, then we could find out that they're equal, I guess.
Equal to?
Each other.
No, of course equal to each other, but more than that, equal to 0.
Yeah.
Yes, both of them should be equal to 0, yes? And that is also guaranteed here. Why? Because can the output, do you know X, do you know Y? No. But I don't need to know the output of an absolute value, I just told you. Even I don't know what is inside, but the absolute value itself is non-negative. Yes, we don't know what is inside, but we don't care up to this point. Absolute value, the output is non-negative. Yes? Is that right or not? But why do you think, can I say that the output of this expression is also non-negative?
Yeah.
Why?
Because it has an exponent.
Not exponent.
Okay.
A particular exponent. Yes?
Maybe it's
Even exponent.
Right.
Yes, because if it is odd, we cannot conclude. But because that's an even exponent, this cannot be less than 0. So you see, from my math knowledge, this is playing the role of A, this is playing the role of B. I know A plus B is equal to 0. How do I know that? It is given in the problem itself. But this is left to me to understand that this is non-negative, this is also non-negative. So what happens? I have two non-negative numbers A and B, the sum is equal to 0. According to what we learned, what is the conclusion? The conclusion is, tell me.
They are equal and 0.
Equal to 0. So this means that the first one is 0. And the second one is also 0. Yes?
Yes.
This was actually important to understand. Okay, now you tell me a number that I don't know raised to power 6 is equal to 0. What can I conclude about this number itself? The number itself is
equal to 0.
0. Yes? Because this number to power 6 is 0, it means that this number is equal to 0. And now, this is the new lesson. If the absolute value of a number is equal to 0, what does it mean?
It is 0.
The number is 0, yes? Is that clear? Because this 0 is the only number whose absolute value is 0. But now I have an AND between two equations in two unknowns. So then it becomes a system of equations. X plus y is equal to 2 if I move it to the right hand side. 2x is equal to 4. And this is a very, very simple system for you to solve, because immediately I can find x is equal to 2, and then I plug it here, and then what I get, 2 plus y is equal to 2. This means that y is equal to 0. But the question mark in the problem is 3x minus 5y, then it becomes very simple. So the question mark is 3x minus 5y. 3 times x, I got x is equal to 2. And minus 5 times y, so the answer becomes 6. So the answer to this problem is 6. 6. Yeah, so that is one of the good examples that it is good to know about this. Any questions? Is that understandable? Okay. So there are some things that we want to, so we learn a new concept, and we have to try to work with this concept a little bit so that we increase our skills in understanding that. So let me ask you some question. What is the difference between this symbol and that symbol? Okay. Yes?
I think in the second one you find the absolute value of x first, and then you raise power 3. In the first one you need to raise power 3 first.
Very good. Very good. So these two operations we have. Here we raise to power 3 and then take the absolute value sign. Here we first take the absolute value sign and then raise it to power 3. So I have the same two operations being acted in two different orders. And whenever these things are there, these orders are different, you shouldn't take them for granted that they are equal. It's always important to check if they are equal or not. Okay, so here, do you think, even though they are different, so for example, if I give you x equals to minus 2 and I ask you to calculate this, how do you calculate this? You replace x with minus 2, and if you want to calculate this, you have to calculate this one first, which becomes minus 8, and the absolute value of minus 8 is 8. And then if I ask you to calculate this one, you write this, instead of x again you put minus 2. But if you want to calculate this, how do you calculate this? You have to do this one first, which becomes 2, and then you have a power of 3, and then it becomes 8. So you see, the way that I write down the left-hand side and the way that I write down the right-hand side are different. And now the question here is that, is this a coincidence that the answers in this case become equal, or this is always the case? So be careful. This way of thinking in mathematics is important. Just with one example, you might be, so even 100 examples, if you bring them and working, it means that they might be still a coincidence. So, but what I'm saying, do you think there is a nice relation between all of them? Or in principle, do you think we make sure that this is always the case? Yes?
I think, yeah.
They are. But if you want to motivate this, how do you motivate that? This is always the case. Because you are not able to check all infinitely possible cases, you need to have a good reason why it will work for infinitely many possible cases.
Should I say it?
Yes, Zohar, you
I
want?
was thinking like because the value, like the answer you will get is positive.
Yes.
So therefore, you will get the same answer.
Okay, but that's intuition.
Yeah.
You need to make it rigorous. So these intuitions are good in mathematics because it gives you directions how to think. But then you need to make it rigorous and tell me this is the case. So if you want to show this is the case, you can consider three scenarios. Yes?
Maybe if x is greater than 0,
Yes.
less
So
than
we need
0,
to consider
equal
three
to 0.
cases, not infinitely many. I consider the case which x is equal to 0. I consider the x positive. I consider x negative. How many cases I am checking? Just 3 cases. And you agree with me that this contains all the cases. Yes, because whenever you choose a number, your number is either 0 or positive or negative. So if I can show under all these conditions this is valid, then it means that this is valid in all cases. Yes? So if x is equal to 0, you just do it in your head. What is the answer to the left?
0.
0. What's the answer to the right?
0.
So that in this case, no problem. If x is positive, can you just tell me first the right-hand side? What is the right-hand side? If x is positive, what is the right-hand side? If x is positive, what can I write instead of absolute value of x? X. And then I have power 3. Okay? Now what would be the left-hand side under the same condition? If x is positive, when I raise it to power 3, it is still positive, and I have an absolute value of a positive number. Do I need absolute value sign in that case? No. So what is the left-hand side? It's x3. So in the positive cases, the right-hand side is x3, the left-hand side is x3, so they are equal again. Yes? And then if I go to the negative one, so let us calculate the right-hand side first. If x is negative, what can I write for this one? Can you tell me? If x is negative, yes, because x is negative, when I want to remove it, I can, but I have to multiply it by a minus sign, and then to power 3, which becomes minus x, multiplied by minus x, multiplied by minus x, becomes minus x to the power of 3. Yes? And then what, so the left-hand side is, the right-hand side is this one. So now we go to the left-hand side. So what is the left-hand side? The left-hand side is this one. Absolute value of x to the power of 3. If x is negative, in this case, because 3 is an odd number, can you be sure about the sign of this expression?
Yes.
It is
Negative.
negative. Now, can I remove the absolute value? Yes, but I am sure that this is negative. The price that I have to pay is to multiply it by a negative sign. So the left-hand side is negative x3. And in this case, again, they are equal. Yes? So we showed that for x equals to 0, the left-hand side and the right-hand side match for positive values. the left-hand side and the right-hand side match. For negative values, the same thing happens. So this is always true. Yes? Is that clear? Okay, so of course, if you want to prove it, you need to consider also even cases or a lot of things, but this is the way that you need to convince yourself. So let me just write it here for you. So if x is for all x in the real numbers, and I don't know, for all n, yes, so they could be from different, let me take it to be n. For all real numbers and for all natural numbers, absolute value of x to the power of n is exactly equal to the absolute value of x to the power of n. So I want you to be comfortable with working with absolute value signs. So if you have a power here and in a problem you need to move it here, feel free, you can do that, okay? But this was the motivation, it is not just coming by accident. So if I have an even power now, the situation is simpler. So here I am talking about all powers, all natural powers, odd or even. But if I have even power, for example, if I have x to the power of 4, if I want to calculate this, according to this, I can flip this 4 inside. But can I get rid of this absolute value, because this one is always non-negative, so I can just safely remove that. So this is very nice. If you have an even power on top of an absolute value, just forget about absolute values. They are the same. So let me just write it here. So if n is even, then absolute value of x to power n is equal to x to the power of n itself. Yes.
Is there no mathematical sign for like even or something?
No.
Yeah, then
Why?
You can write a statement which means that this is even. So you can say that n is equal to 2k, where k belongs to n. Then this means n is even, because it means it's a multiple of 2. Yeah, but just saying even, I would prefer to write even.
Yeah, of course.
Okay. Okay, let me ask you to simplify one question. So the exercises are aiming to make you more and more comfortable with working with this absolute value sign. Okay, so I would say simplify. Okay, so number one, absolute value of x squared, let me write 2 here. Absolute value of x squared minus 1 divided by x minus 1. Of course, here I am assuming that x is not equal to 1, otherwise this does not make sense. Another one which is more interesting, let me also solve this one for you. Absolute x plus its absolute value divided by 2 to the power of 2. Is it plus or minus? Plus. X minus absolute value of x divided by 2 to the power of 2. Let us feel more comfortable working with the absolute value sign. Let me write one more here. So number 3. X squared of course in this case x shouldn't be equal to 0. Even if I don't write it, I implicitly means that when this is meaningful, otherwise this is useless. Okay, so I will pause the video a little bit so that you can think about this yourself first. Okay, so do you have any suggestions for me here? Of course, for absolute value signs, you can always start discussing about different scenarios. Is it 0, is it positive or negative, and simplify in each case. That is not wrong, of course. But I want you to do it more efficiently if possible. Sometimes it is inevitable. We have to discuss about different cases. But here, for example, do you see any way out of it because of the rules that you have in mind? Yes.
Well, if n is even, then the absolute value of x to n is xn, so you can just take away.
Yeah, that's it. So this is, I'm using this fact that because of an even power, I really don't need the notion of absolute value in the first place. So what I do, I would say this is equal to, then it becomes x squared minus 1, then it becomes a Mat 2c problem, if you haven't forgotten that. So what should I do now? So I hope that you remember you are not allowed to simplify these x's because you can only simplify if they are factors, yes? So if they are factors, you can simplify. If I ask you to read this, is it a product, is it a difference, is it a sum, you definitely say that is a difference. That's also a difference. So if you say this is a difference, it doesn't mean that x squared is a factor. X squared is a summand or something, and you are not allowed to simplify numbers except they are common factors. So you have to make up, you have to make common factors appear if they are. So if there are any actually. So what I do you remember? This is the conjugate pattern, yes? So it becomes x minus 1, x plus 1. Do you remember? If I have a number squared minus another number squared, I can write, this is a very, very famous pattern. Yes, and this is this one. So the reason I could do this because 1 can also be written as 1 to power 2. There is no difference, and then I can immediately use that pattern. Any questions? Okay. And now in the denominator I have x minus 1. I cannot do better than that. Now, is the numerator in this form a product? Yes, that's a product between these two factors. And this factor is also exactly the same. So I can take this away, and then the answer becomes x plus 1. So instead of working with this expression with absolute value sign involved, I can just simply work with x plus 1. They are exactly the same. Yes? Okay. Now we go to the second one. What do you think I can do for the second one? Of course, you again can start discussing about different scenarios for x, but can I do better? Probably yes. Any suggestions for this? No one from this side? Yes, Rocco?
So let's start off by expanding, the power. So we have x plus absolute value of x squared. Then we use the squaring pattern, but
Exactly.
we have to keep the
Exactly.
We have to keep for
But before that, what do you think about fraction?
The denominator we can do is just 4.
Yes. So exactly. So if I have a fraction raised to any power, that is just old lesson. It becomes the numerator to the power of 2, denominator to power 2. So I would write this patiently like this: x plus absolute value of x to the power of 2 divided by 2 to the power of 2, which is 4. And then I go to the next one, the same idea. And then good point is that I have the denominators the same, so I can make the common denominator, which is 4. And as Rocco mentioned precisely correctly, so you need to use the squaring pattern. This will play the role of a plus b to the power of 2. I hope that you haven't forgotten that. It becomes the first one to the 2, 2 times the first one times the second one to the 2. And if this is subtraction, you get a negative sign. So 1 with positive sign will work here, with negative sign will work here, yes? So the first 1 to the 2 is x squared plus 2 times the first one times the second one, it becomes 2x dot absolute value. The second 1 to power 2, And then the same thing for this one. The first one to the 2 minus 2 times the first one times the second one, and the second one to the power of 2. Just let me know if there is something confusing you here. Understandable? Okay. And then you see this one, we don't care what is this, but we have the same thing here with negative sign. So what happens is that I can get rid of I don't even care about the sign of x, because this term will cancel that term. And then we just learned today in the previous problem, so x squared with x squared is what? 2x squared. By the way, let me, before doing that, what can I write for absolute value x squared plus absolute value of x squared? That is a package. I am adding another package of the same thing to it, so it becomes 2 absolute value of x to power 2. Is that understandable? I have one absolute value x squared. I have the same thing again added to this. So it means I have 2 of them. And then I have divided by 4. But now we learn that, do I really need absolute value sign here?
No.
No, because this is an even power. So that is even power, so just get rid of it. So what happens, it becomes 2x squared plus 2x squared divided by 4. I want you to understand. The reason that I was able to get rid of absolute value is not because I am sure about that x is positive. No, because that power is even. Yes, in that case we don't need to be worried about that. But 2x squared plus 2x squared is what? 4x squared, and then divided by 4. Yes, and then this is x squared. So you see, that was actually ridiculously complicated. So instead of working with this expression, we can just work with x squared. So for example, in the exam, if I ask you, do you know the diagram or the graph of this function? You would say yes, because there is no difference between that function and this y equals to x squared. So that's the parabola. Yes. Is that understandable? So these exercises, the goal of these exercises is because I want you to feel comfortable working with these absolute values. Okay, what do you think I can do for the third one? Again, I hope that you agree that we cannot simplify this with that. Why? Because this is a summand. Yes? If I ask you, is the numerator a product? You should say, no, this is a sum. When you say it is a sum, these are no longer factors, they are summands. And summands cannot be simplified. Yes? So what do you think I can do here? Either I can discuss, I told you sometimes it is inevitable, I have to consider different scenarios. We know that x is not equal to 0. We can solve it and consider x is positive to see what happens. Once again, we consider x is negative to see what happens. And then if we can glue them back together, or if we cannot, we can just write it as it is. Okay. So yeah, let me solve this one in 2 ways. Okay, first let me solve it by discussion. Let us see how it happens. Okay, so let me clean this. Even though there is a better, more efficient way for this one, but I think this is also a good experience if you learn that one as well. So number 3, x is not 0, it is mentioned in the problem, so there are 2 scenarios left. Either x is positive or x is negative. Yes? So let us consider the case A, x is positive. If x is positive, what can I write instead of absolute value? Just tell me. What can I write? X. Because you are telling me now x is positive, so I don't need to. So the question mark becomes equal to, instead of x squared, I just simply write x squared, but instead of absolute value, I put x. Instead of absolute value in the denominator, I put x. Can I simplify this x with that x? Yes or no? No, because they are not factors now. So I have to factorize the numerator. But this is very simple. I pull x out. And then can I simplify this one with that one now? Yes, because they are factors. So the answer becomes x plus 1. So what we learned that if x is positive, the question mark is x plus 1. That is not wrong. That is completely correct. But let me write the other one. Part B, I need to consider the case that x is negative. Now tell me, if x is negative for sure, can I get rid of the absolute value sign?
Yeah.
What is the answer? Minus x. And now again, let us go back to question mark. X squared plus absolute value of x, but in this case, absolute value of x is negative x. And then I have what? I have again negative x. Yes? So I have replaced every absolute value of x with negative x in this case. Is that understandable? Yes? And now what can I do again? I can factor an x out. It becomes x minus 1. And then I have minus x. This x and that x are cancelled. But 1 is left from here. From this one, minus 1 is left. So this becomes what? This becomes x minus 1 divided by minus 1, which of course is negative x minus 1, which becomes what? Negative x plus 1. Yes? So you can say that if x is positive, my answer is that. If x is negative, my answer is this. This is 100% true and right. This is not wrong, but I don't like it. The reason I mention it because I want you to learn this skill as well. Can I glue these two solutions in one formula? So you see here, I don't know, I broke this problem into two problems. I got two individual answers. One works under this condition. One works under this condition, no problems. It's okay. But now can I glue it back into one single formula? So can you tell me, if I glue number 1 and 2, what can I write at the end with one formula? So let me tell you something. Here, what you have shown, you showed that the question mark is x plus 1 if x is if x is positive, and you showed that it is minus x plus 1 if x is negative. I want you to learn this skill. Instead of writing so much, you can compactly write it as. If you can answer this question, you understood everything actually. Let me repeat my question. So do you agree with what I have written on the board? According to what I have calculated, under this condition, the answer to question mark is this. Under this condition, the answer to this question mark is this, based on my reasoning that you have seen and followed here. So in principle, if someone asks me what is the answer to this guy, I don't have one answer. I would say that the answer to this guy is this if x is positive, is this one if x is negative. No, nothing is wrong here, 100% right. But I want to glue these two formulas into one simple compact package. Yes, Maximilian?
Plus minus x plus 1.
No, that's not good. Because when you write plus minus x plus 1, what is the point? Then you have to write when it is positive, when it is negative. So what Maximilian said is probably close. So you say that you write plus or minus x plus 1. Then people doesn't understand the same thing. Because if you just simply write this, then people doesn't know when they should choose the positive sign, when they should choose the negative sign. Do you agree? Because here you should mention when positive, when negative. Yes, Hussein?
Wouldn't the mathematician use absolute value of x plus
1. So that is what I want you to learn. Instead of writing so many things, I can just simply write that. Is that understandable? Because the person who knows absolute value, they will interpret it in this way. They will say that if x is positive, absolute value of x is x, and then I get the same answer. If x is negative, absolute value of x is negative x, and then I get the second answer. So this is the reason people used to work with absolute value signs. Instead of writing and explaining things in words, we just write this. The people who knows absolute value translate it in the right language. Is that understandable? So the reason that I solve this problem in this way, because I want you to learn this gluing things back. If possible. Sometimes it is not. Okay, but if possible, I want you to learn how to glue it back. Is that understandable? Instead of writing so many things here, I can just simply write that. I want you to understand there is no difference between this statement and writing so many things. It is different from what Maximilian said. Because in that case, it seems to be right, but when I write plus and minus x plus 1, then you don't know when I should choose the positive sign, when I should choose the negative sign. But when I write absolute value of x plus 1, you understand that part yourself because of the definition of the absolute value. Is that understandable?
Yeah.
Yes or no?
Yes.
Okay, good. Now, what is the better way to do this? This is 100% correct. If I ask you what is simplify this, if you write this is correct, unless I tell you that, okay, you have to write it in the absolute value form. And then you need to do one more step. But can you see a much more efficient way to do it in under 1 or 2 seconds? We can just come to this answer immediately. Yes? Let me just clean the board. When I'm cleaning, you can think about it. Okay, time is finished. So what should I do? X squared plus absolute value of x divided by absolute value of x. That's it. So what can I do here? Any suggestions if I want to do it more efficiently?
But you could just simplify it without ever removing the absolute value.
So how?
I'm not sure, but I guess that's what you would do, right?
Okay, but you need to find a way. Yes, you are right. But in this case, can I factor something out in this form? In x squared plus x, I could factor an x out because x is indeed a common factor. But here I have two factors of x, x times x. Here I have one factor, absolute value of x. Absolute value of x is not exactly equal to x. Sometimes it is, sometimes it is not. Yes, Abdullah?
You write x to the power of 2 like absolute value.
That's the case, yes. I can, instead of this one, I can write this one to power 2. There is no difference between them. Yes? And then I have this absolute value of x. Can I factorize something now in this form? Yes, and that is absolute value of x that I pull out. What is left from here, can you tell me? Absolute value of x plus 1. And then
Absolute value.
this one and that one are simplified. And then what I get the final answer. So I want you to learn to do things more efficiently. Of course, there is nothing wrong with that one. The reason that I followed the previous method, because that is also an important skill I want to teach you. So this you'll learn. But I would prefer to do it in that way myself, because this is much more fast. Is that understandable? Yes or no?
Yes.
Okay. There is something extremely important now. I want to emphasize on that, but before that I want to motivate you. So if I ask you, how many of you agrees with this one? A squared, square root of a squared is equal to a.
Yes.
Yeah,
Is that right or wrong?
that's right.
Yes, but this statement is false. So you have to be careful about that. Let us see why. If you naively simplify these two things, sometimes it is true, sometimes it is false. Okay, for example, if I ask you 2 to the power of, let me change this number to 5. 5 to the power of 2, what's the answer to this? This is 5, definitely true. But let me ask you this. What is the answer to this? It is 5 again. But if you follow this rule, you are telling to yourself that whatever A is, the answer is this one. So here, this is playing the role of my A. So the answer according to that formula should be this one, but this is false, yes? Because if I ask you, do you know how to calculate this? You would say yes. Minus 5 to power 2 is 25. Square root of 25, you just use your calculator. Always and always you get 5. So if you just think this is the correct formula, this is not the correct formula. It works when A is positive. But when A is negative, this is not correct. So the formula that is always correct is this formula. From now forever, okay? A square root of A squared is not A, is absolute value of A. Yes?
Wouldn't you write the sign before A so that you know if it's positive?
No. In algebra, if I ask you to write something in front of it without the search sign, you should write this, and this is possible. When I ask you in that way, I don't know if A is positive or negative. Yes? So be careful. But what do you think about this one? Can I write A? Yes or no?
No.
Yes. This time, yes. Because for even odd powers, we don't have any problems here. But the problem arises when this number and that number are even numbers. Okay? So is that understandable? So let me solve this problem using this formula. If I want to solve minus 5 to the power of 2, what should I write? If I know my homework, if I have done my homework properly, I know this is the right formula. So I write absolute value of minus 5. But what is the answer to absolute value of minus 5?
5.
It's 5. And then what is the real answer? It's 5. So we don't make any mistakes. So remember that. So let me write, this is an extremely important, so let me write this. So I would say that the nth root of a to the n is equal to a if n is odd, and it is absolute value of a if n is even. Okay? So extremely important. So this I want you to know. I don't know if this is in the formula sheet or not, but probably not. So you need to know that if I have these two numbers, this is not always 100% the case that you can get rid of everything and simply write a. Yes, if n is odd, that's guaranteed, that's always true. But if n is even, you have to be more careful and write absolute value. Of course, if a is positive, you don't need to be careful again. You can simplify because there is no difference between absolute value of a positive number and the number itself. But in general, if you are working in algebra and you don't know anything about the sign of a, if you write a, that might be wrong. Unless you know a is positive. But if you don't know about the sign of a, and you know that this number is even, if you just simply write a, that is wrong in general. Is that understandable? Yes or no?
Yes.
Okay, good. Let me, for example, give you an example. Let me make it multiple choice question because to see how do you answer. I would say example. So let x be a negative real number. Then x squared minus the square root of x squared divided by x squared minus 1 is equal to, so I want to give you 4 options, one of them, and exactly one of them should be true. X divided by x plus 1 to x minus x over x minus 1 number 3, x over x minus 1, and a 0. So let me, I have been a little bit careless because the denominator should, so I would emphasize here, x is not plus or minus 1. Because in both cases I will have problems with the denominator. The denominator cannot be 0. By the way, in these kinds of questions, when they ask you, this means that implicitly they are telling you that x is not plus or minus 1, because otherwise this doesn't make sense in the first place. Okay, I want to pause the video a little bit, and then you have your formula. This if you solve this problem in a nice way, it means that you understood what I said here, okay? So I will pause the video for you a little bit. Okay, do you have the option, the correct option? Yes?
3.
Number 3, you are saying number 3, let us check. So Rocco. Anyone? That is 3?
Yeah.
Okay, so Robert. Okay. Robert, Rocco, Casual, yes? Okay. No, you are not saying that? Okay. So, R squared. Yes? No one else? Yes?
I got it. So 3.
The same.
We got it.
Yeah, so-
cubed.
Triple R, yes? Yes. Okay, so that I think probably that is the correct one. Let us see. Okay, if you haven't done it right, this is you that you have to teach yourself why you made a mistake. Yes, I did my role here. If you of course don't understand, please let me know. But otherwise, you should be able to solve this. This is not a hard question. So I want to have this question mark. So let me just write it in front of our eyes. So it becomes this divided by x squared minus 1. Okay, so it is clear, probably before this lesson, if you want to write something for this one, you would have written x. Now you learn that this is not in general true. Yeah, so you have to respect the rules in mathematics. So here, n is even. So if I want to write something right in front of it, that is not x. This is absolute value of x. Not because that I am teaching you the absolute value signs. From now forever, square root of x squared is no longer x, it is absolute value of x. Yes? It becomes x if x is positive. Be careful about that. Yes. Now, I want to get rid of absolute value sign. I told you that most of the time we have to get rid of that. Can I get rid of that? Yes, there is an extra piece of information that helps me to do that, and that is mentioning that x is a negative real number. So I can get rid of that absolute value sign. So, but the price that I have to pay is to write what?
Minus x.
Minus x, which there is another minus sign here, becomes
Plus.
positive x divided by x squared minus 1. Do you realize that it was a wrong mistake? If you have just written as normal before, you would written x squared minus x, which is wrong because the correct one is x squared plus x. Yes? And then what you need to do is just math 2c. You have to be able to simplify that. Simplifying means factorizing the numerator, which is x times x plus 1. And what the denominator is the conjugate pattern, yes? So it becomes x minus 1, x plus 1. And then this factor and that factor are gone. So what is left is x. What is left in the denominator is x minus 1. So the triple R actually did great, yes? So that's the correct answer. And in these kinds of questions, the people who have actually designed these questions think about what students might think, and they put that answer in the options. So that is a little bit dangerous if you just are not very careful. For example, if I haven't been careful and I have written this as usual, then I can factor x, and then this one and that one are gone, and then I have chosen option number 1. Yes, so that option number 1 is also there. And the point is that if you choose option number 1, you not only lose the question, but you also get a negative number, a negative score. Because in multiple choice questions, there are negative scores preventing you from random guessing. So you not only don't get 0, you get probably minus the third. We're answering such a question wrong. Okay, any questions so far? Okay, so let me try, because this is very, very important. I want to give you a little bit more examples here so that we understand this better, okay? I don't know, I will talk a little bit about drawing the graphs later, but let me just start with this example now. Draw the graph of the function y is equal to x plus square root of x squared minus 4x plus 4 for draw the graph of the function that lies on the left hand side of the vertical line x equals to 2. Yeah, just write it, I will explain before letting you solve it. So it seems a very complicated problem, because how to draw the graphs of the square root signs even is not the part of your studies in high school. You will learn them in the university, but not for this problem. You need to be smart enough to understand how this relates to the lesson today. But let me just tell you that, for example, if I give you, what do I mean? Assume that this is a graph, and then x is equal to 2. On the left hand side of this graph, I am interested in this part of the graph, which lies on the left hand side of x equals to 2. So I'm asking you, draw the graph of this function, of course, on the left hand side of this vertical line. I don't care how the graph looks like on the right hand side. I care about how the graph looks like on the left hand side of this vertical line. That's the question. Yes? Yeah, we have a little bit of time, so I will give you at least to think how this question is related to the notion of absolute value. Because you know, by the way, the hard part of mathematics is that when you go to the next year, if you see a question, you need to immediately find a connection between your math knowledge and the question. That is the hard part. Here, all my examples are somehow related to the absolute value sign because I am teaching you absolute value. Yes? But later, you yourself need to understand that this question is related to which part of your math knowledge that you have acquired before. Okay, so just let me pause the video a little bit. Any progress? Okay, because you told me that you could detect a pattern, then after that it comes immediately, I would say. So can you help me? So what is the pattern if I want to draw the graph? Let me change the color here, it doesn't work. So y is equal to x. Okay, how many of you could detect the pattern? What is the pattern under the square root? What is that? Just say it. X minus 2 to power 2. Everyone agrees with that?
Yes.
Yes or no? Okay. But then, we just learned something today. Am I allowed to get rid of this? Yes, the price that I have to pay because this is even, I have to put absolute value sign. Yes? There is no exceptions. Yes? But I am not interested in the graph of this object as a whole. I am just interested on the left-hand side of this vertical line. When I say I am on the left-hand side of x equals to 2, it means that I know something about how great can x be, at most 2. Yes? On the left-hand side means that x is less than 2, because I am interested on the left-hand side. Yes? Understandable or not? So it means that, can I get rid of absolute value sign now? Because I told you, whenever you want to do something with an expression with absolute value, the first thing is to get rid of absolute value. Okay? So here, x is less than 2. It guarantees that this number is negative. Yes, because x is less than 2. And then it is negative. Am I allowed to remove it? Yes, the price that I have to pay, in this case, to multiply it by a negative sign. Yes or no? So then, if I multiply, it becomes minus x plus 2. And then what I have is this function. So therefore, what is the function that I am looking for? The function is x plus this expression. But this expression on this condition is minus x plus 2. So what the answer is?
Y equals to 2?
2. And is this hard to draw the graph? It's just a horizontal line passing through 2. Okay? So if I want to draw that, so this would be the graph. So I would say that if this is 1, this is 2. And here this is 1, this is 2. So this would be the graph on the left-hand side. Yes, up to that point. So this is very simple. Now, let me just ask you one more question. Instead of asking you draw the graph on the left-hand side, let me ask you to draw the graph without any limitations. Okay? So draw the graph, the whole graph. Okay, without mentioning these sentences. Of course, we did it, one part of it, yes? On the left-hand side, the graph is this one. What happens if I am on the right-hand side of 2? But that is also simple to answer. Can you tell me what should I do on the right-hand side? So on the right-hand side of 2, x is greater than 2. Yes? So what happens if x is greater than or equal to 2? Can I remove the absolute value sign?
Yes.
Yes, but the answer is x minus 2 itself. Yes? And now, this is x plus absolute value. So the graph on the right-hand side is that x will combine with that x, it becomes 2x, and then I have minus 2. Yes? But is this something hard? No, again, in Math 1C, you know how to draw the graph. That's a line. Yes? That's a straight line. How should I draw the graph of a straight line? I need 2 points of the graph, x and y, and then I connect them together. Yes? For example, let me choose x equals to 2. The answer would be 2. Because I am now on the right-hand side, let me choose something greater than 2. For example, let me choose 3. And then I put 2 times 3 is 6, minus 2 is 4. And then I will find these 2 points. x2, y2 is exactly this point. x3, y4. x3, y4. That's also another point. Okay? And then I connect them and continue. Okay, the question is that, should I also go in this direction? No, because even though this straight line goes to infinity from both directions, but I shouldn't continue in this direction because this becomes the graph if x is larger than 2. So it means that the graph of this function consists of 2 parts, one horizontal line, it is not a line, one horizontal ray, it starts from here, goes to the left, and one inclined ray, starting from here going upward. So that would be the graph of the whole function. Yes? Is that understandable for everyone? So, yeah, I would consider it a hard problem at the level of your book, but that is not hard at all. Yes? Yes?
How do you write conditions in the algebra?
there is an if, you just Google it, I don't remember. So for example, you say if, yeah, that's a good question. Yeah, I will try to fix it out. Okay, I will try to answer this. But there is, if you just type if, something appears. If you want to have some function with more than one formula, you use the if condition. Yes?
You do that.
Yeah, we can probably do it here, but let me just pause the video. We have a little bit of time, so let me just do the GeoGebra. That's also a good question. But before doing that, any questions here? Is that understandable? Yes? Okay, so that is what we actually realized from the graph of this function. But for this question, you have to draw only the horizontal part. But for this question, the whole graph is needed. Okay, let me just pause the video and see that if we can combine the frame. Yes, that's good.
To infinity and beyond.
Yes, I go here. Now everything is being recorded. Okay, so here, let me just put that function. First of all, I want you to know about absolute value. Absolute value, if I am right, in these languages is ABS. Yes, it understands that. For example, y is equal, I will come back to it later, but ABS, absolute value, you press X, and that's the graph of absolute value. And by the way, why absolute values are important in our lesson, is this graph a well-behaved function? No. Do you remember there were two conditions for being well-behaved? Continuity and not having sharp points. So this one is not well-behaved because at the origin it has a sharp point. The reason why the graph is like that, that is at the level of your knowledge now. If you are interested, you can find that one as well. But let me just clean that and then put our function there. Okay, so let me get rid of that. So our function was y equals to x plus square root of, and then we have x to the power of 2 and come down, yes, minus 4x plus 4, yes?
Yes.
And that's exactly the graph that we generated. Yeah? So this GeoGebra is also capable of showing that. So you see, that is the graph, consists of one horizontal part and then this inclined line, exactly as I drew here on the board. Okay? So you see, it was not hard. So the graph, the absolute value is a very good tool in our hand, because if we want to break the graph of a function sharply at that point, we probably can use the notion of the absolute value. Again, is the graph continuous? The answer is yes, but it is well behaved? No, because still it has a sharp corner. Yes? So we will study that later. The function is continuous everywhere, but it is not differentiable at x equals to 2. So we can also discuss about that. Okay, by the way, let us see that if GeoGebra is capable of simplification of those expressions, but I don't know. We can go to the view and change the view to cast view. Yes. Okay, so we don't need this view anymore. Okay, so do you remember what was, so there are some conditions. Yes, I think the condition should be if, yes? Is there any if? Yes, you see there is an if condition. For example, this is answer to your question, Hussein. So if condition, then else. So this means that if, let us see how it works. If x is greater than 0, then you go, for example, x plus 1, yes, else I go here, I don't know, so else, for example, 2x minus 1. So I think this is the way that GeoGebra knows about if. So you are telling GeoGebra, the function that I am interested, if x is greater than 0, my function is y equals to x plus 1, otherwise it is 2x minus 1. Okay, so the otherwise means x is less than or equal to, I don't know, let us see what happens here. Yeah, that's it. But can I draw the function here? So can I write y equals to? Or should I define a function? Okay, so might be I have to define a function not in this environment, because if I want to draw it, I don't know, can I copy and paste this one, take it with me or not? No, it doesn't work. Okay, so let me graphics No, algebra view, and then I get rid of this. Let me just test the idea once more. So if, let me make it simpler so that we understand. If x is positive, I will consider it as x. Otherwise, I will consider it as minus x. I don't know. So, yeah, you see, this understands. Yeah, Hussein, do you see? This way of writing is if. So when I wrote if, I don't know, I entered so you see this one. I wrote if x is positive, take it x, otherwise take it minus x. When you enter, you get exactly the same conditions. And I told you that usually you do not have the word if. This way of writing in mathematics means g of x is equal to x if x is positive and is equal to minus x otherwise. Okay? So for example, can I draw the graph of this function? Probably yes. I should be able. But where is this one? Where is the graphing? I have actually. Yes. I have to make this one also clear. Yes. And then this is exactly this function. You see, if I take this one, because this is the definition of absolute value. You see, when I open it, it becomes exactly absolute value. So the answer to your question, Hussein, if you heard me, did you hear me? Yes? Okay. So that is if. But that was a good question here. Okay, any questions? Can we do something nice here in GeoGebra? Probably later. The main thing that we want to learn next time is how to solve equations. This is the main topic of this lesson. How we solve equations and inequalities containing absolute value sign. That would be the last. Of course, that might take 2 sessions to finalize, and then after that we continue with the other part of the lesson. Any questions? No? Okay, thank you very much. Thank you.